Okay, for question 4, it is about your manometer, and again this question is taken out from your pressure worksheet. So first, we want to find out whether you could explain how does pressure arises from a gas. We also want to see whether you understand what we mean by saying using the kinetic model of matter. So basically, kinetic model of matter is just that whether you could explain this particular phenomenon, pressure, using the idea that matter consists of randomly, constantly moving particle. So in this case, what we want to see is that you could relate pressure with the thing that is responsible for it, in this case, the gas molecule. And then whether you are aware that the key highlight of the kinetic model of matter is that these particles are always in random motion. And we want to find out that whether you could articulate that how this motion eventually turns into or give rise to gas pressure. So we want to see whether you can articulate that, oh, this motion, because of this motion, the gas molecule will collide onto the wall, therefore exerting a force on the wall. And because the wall is the surface that will give rise to the pressure, because pressure equals to F over A, right? So pressure equals to F over A. So by saying that gas consists of molecule and this molecule will collide onto the wall, thereby exerting a force, you have identified what is F. How about A? What is A? Well, A refers to the wall, right? The wall of the barometer, the wall of the container. So as long as you can tell me that, I will give you the full credit, including if you tell me that the gas molecule are colliding on the liquid surface, which is referring to here. All right, so that is your part A answer. Okay, for B and C, I'm not very happy, especially for those who didn't got it correct. You can see that, again, there is this feeling of panic when students see this question. And as I was sharing at the earlier video about question 2, whenever you panic, right, do not just hum-tum. Hum-tum means anyhow try. If you panic, always go and think and try to recall the safest approach. Every topic in your physics chapter has a central idea, and you can always rely on this central idea to solve all the questions under the topic. So for your manometer, what is the central idea? The central idea is that the pressure that is along the same level will have the same pressure, meaning that these 2 points has the same pressure. But should you choose this level as for you to apply the thing? Well, I won't choose this because it is quite awkward, right? What do I mean by awkward? If I choose this, I want to find out what is this pressure at this point, P1. Well, pressure at this point will consist of pressure from this column plus the pressure that is coming out from your gas supply. I would have to deal with this column, which I don't know how deep is it. I don't know how deep is this. So if I choose this level, it will create more inconvenience. So what is the best level to choose? If you are from my class, I would have already shared with you the go-to level is always the lower level of the two. So if you choose this level, right, you want to go and calculate whatever thing, it always go back to that central idea that pressure along the same water level give you the same pressure, right? Let's say you look at this question and you're like, what is this? Should I do this? Should I do that? Right? You are guessing. Once you feel that you are guessing, it means that don't risk it, right? Chances are the guess is wrong because we will set the question, we will create misdirection there to actually give you a higher risk, give the teacher a higher chance to better differentiate the student between one that really understand and those that guess. So we will put in some misdirection in the question, whereby if you are guessing, most likely you will be misdirected. So if you feel that you are already guessing, go back to the first principle. For manometer, first principle is pressure along the same level is the same. So I decided to look at this level because I feel that it is more convenient, right? And if you don't know what convenient means, you can ask your teacher. Convenience in the sense of solving physics question. Let's say you are already running out of bandwidth. To choose a convenient level means you pick the level that is the lower of the two, right? Then you tell yourself, okay, pressure along the level is the same. So meaning P1 equals to P2. Okay, then carry on your deduction. So this is for part B. Okay, so this is for part B. Right? Pressure 1 equals to pressure 2. Right? Then next step. Pressure 1 consists of what? Pressure 1 consists of the pressure that is coming down onto this level by the gas supply. Okay, so this is P gas. Pressure 2 consists of the pressure coming from this column. So I say pressure of the column 85. Right? On top of this column is vacuum, so got nothing. It is a closed end, meaning that atmospheric pressure cannot come in as well. There is a rigid glass wall that separates this space from the rest of the surrounding pressure. So there is no atmospheric pressure. What is my gas supply? It is the same amount of pressure as 85 cm of mercury pressing onto a surface. So that's why here, don't need to do so many things. It's just 85. What do I mean by misdirection? Misdirection. Right? Those who guess confirm will gonna this misdirection. Right? Because we as teacher, we know how to misdirect you. Especially those that just want to learn. Right? Some of you may be, how can it be so easy? Just read 85. Yeah, if you guess, it's like that. So the moral of the story is, once you are not sure, go back to first principle. Right? What is an even better strategy? Practice until you are so confident that you can see through our misdirection. How about part C? Well, part C, there are some changes. It says that due to aging, air leaked into the closed end, and now the manometer changes to 78. First, what we are doing is that I want to check whether you understand what it means by the reading of manometer. Where do you read the manometer? Do you know? Okay, so for those who didn't know, it means that this value in part C has changed. This is referred to as the reading of the manometer to 78 cm. This one is the reading of manometer. Okay, if you do not know this, you will fall trapped. You will feel, I don't know what is going on, right? And we also know that now in C, there is going to be pressure over here, inside this thing. So there is some air inside. And if there's air inside, there will be molecule. And as you have explained earlier, right, as long as there is gas molecule enter into this space, the gas molecule will collide with the walls on the in the space, and we will exert a pressure. So now we call this pressure of air that is inside this initially vacuum space. So now in C, how will your equation look like? It's the same, right? Pressure 1 will still be equals to pressure 2. Pressure 1 is still consists of pressure of the gas supply. Pressure 2 will consist of the column over here, but in this case the column has already changed, right? And then instead of a vacuum pressure, which is 0, now you have pressure of air, right? In B, you have already find out what is the pressure of the gas supply, which is going to be 85 cm Hg. Pressure of the column now has already changed to 78 cm of mercury. So 78 cm of mercury. The pressure of the air inside this initially vacuum closed space, we do not know. Right? And that is what we want to find out, right? So your P air, right, which refers to the pressure over here at the closed end, can be found by 85 minus 78, which will give rise to how much? 85 minus 78 will give you 7. 7 cm Hg. Remember for physics, 2SF. So you see, as long as you are anchored on the core principle of how a manometer works, no matter how we change the context of the question, you'll be able to get the answer. The idea is when you are panicking, when you are guessing, go back to the first principle.